So I'm glad to see you on my course. The course is called Additive Technologies from Macro to Nanoscale. And today we will consider the first topic. It's about main features and differences of main features and differences between additive manufacturing and traditional methods of manufacturing. So here's the plan of the lectures. I made this slide just for your convenience because there was some schedule at the beginning and I've mixed it a little bit. So on the right part of the slide is the correct plan. We'll start from differences between additive manufacturing and traditional methods. Then we'll consider the classification of main 3D printing technologies. Then we'll discuss some software. Then we'll discuss some the preparation and creation of 3D model. And then we'll start to discuss in details different methods such as extrusion methods, powder methods, inkjet methods, 3D bioprinting, photopolymerization, lithographic and hybrid printing methods. And then we'll move to electrodeposition of ions in liquid, focused ion beam-induced deposition, and leaf printing. So at the beginning, I was planning to discuss some commercial methods and then move to scientific ones. But after that, I realized that it's better to discuss them together because they're mostly are based on same physical principles. And when we discuss the extrusion methods, it's also convenient to discuss at the same time, for example, laser-induced directing writing methods. So I've mixed it, and now I'll start to move according to this plan. So additive manufacturing, what is it? So the definition of additive manufacturing is that it's a class of technologies which create object by adding material instead of subtracting it. Mostly it's in adding layer by layer fashion. Why mostly? Because there are some technologies that doesn't use the layer by layer approach. For example, two-photon polymerization, which work with voxels, or laser-assisted DIY, and others. So that's why mostly evolved, but the difference is that it's adding material instead of subtracting it. So as you might see on the picture, you start with the material. Depending on each technology, it comes in different forms. Let's consider, for example, fused deposition modeling. It comes as a filament, and you're adding a layer by layer until you get the 3D object. This one. So the benefit of this method that you have very little amount of waste. The waste is mostly of all comes because of the supports. The support structures is a specific structures which helps your material not to fall down. And again, different approach used the supports in different forms. We'll talk about that later. In subtractive manufacturing, you take the raw material as a bulk material, and then you subtract all the material you don't need to get the 3D object. So you have the big amount of waste, and when you produce small amount of parts, it's very economical, beneficial to use the 3D printing. So in the beginning, you have the 3D model, then you turn it into the STL, triangulation format, then you print it, then you have the post-processing, and you've got the model. So it's very briefly about the approach. So let's consider some benefits. Once again, the benefits of additive manufacturing is the reduction of time and cost of starting the product in the production line due to the absence of the need of specialized tooling. What does that mean? When you want to create, for example, a plastic form, if you use the traditional methods, you have to make the master form and then you have to mold it. If you use the 3D printing, you don't have to do that. You only you just print your model once. So that's lead to very big reduction of cost because the master form are mostly of all very expensive. So the other benefit is that there's a big economic feasibility of small-scale production and the production of customized products due to the same reasons. So it's also the operational changes in project at the production stage due to the same reasons. The functional optimization of the products, that one is because you can create the object of very complex 3D forms. You don't have to make it very simple. For example, it's very useful in production of cooling channels. And also there's very big amounts of works devoted to the so-called topology optimization. When you use the bio-inspired forms to optimize the mass and the strength of the parts you create. So there's also the reduction due to waste production, the possibility for logistics simplification and deliveries. So if you want to create something somewhere, you don't have to travel all the materials and parts to the place where you need them. You can print them on place. For example, at the moment there's a pretty big amount of works devoted to production of parts in aerospace. Yeah. For example, there's the 3D Biosolutions company, which created the bioprinting device to print objects in space. So they are starting to carry out different experiments about that. Yeah, and there's a design personalization. So there are a pretty big amount of works in medicine, in customer goods, which produce the personalized parts. For example, the prostheses, different types of the earphones, for example. So the professional DJs make the earphones which repeat the shape of the ear to make the better noise cancellation, and many things like that.